Thank you. I'm going to talk about geological studies of the moon and a little bit of review and providing some perspectives. So next slide, please. Next slide, please. Yeah, so starting from the explaining the field of geometallurgy, which is about integrating the mining-related fields to maximize the value of an ore body while minimizing the technical and operational risk. So commonly the combination of geology and metallurgy part, specifically mineralogical studies in combination with mineral processing and hydrometallurgy. So that is about the field of the study. Next slide, please. So in terms of specific to the geology of the moon, the limited studies were found on the subject. Specifically, the literature reported ilmenite considered one of the major mineral phases on the moon surface, and they studied ilmenite. Next slide, please. Yep. So one of the report studied mineral liberation and association of the rigorous stimulant and upload return samples. And they indicated the importance of characterization in terms of mineralogical characterization, chemical characterization, and so on. So one of the important aspects which can be strongly connected to the mineral recovery and the selective separation is about physical properties, including particle size, shape, composition, and density, in addition to the mineral liberation and association. So I'm going to talk about specifically particle size and the liberation aspect in this talk. So next slide, please. So in relation to the separation methods to recover the minerals from ores, we can use a different separation methods which has a suitable particle size range. That's why we are interested in having a good particle size range and together with a good liberation of target minerals from the non-target minerals. So here you have a schematic explaining the particle size range suitable for the different physical separation methods or the physical-chemical separation methods. Here you see the physical-chemical separation methods, so-called frost flotation, using the air bubbles to recover the hydrophobic minerals and separating from the hydrophilic mineral. So there is some argument, but typically it says there is a suitable particle size range from 10 to 20 micron to 100, 200 micron. So that is a suitable size range for the conventional mechanical flotation cell. So next slide, please. So what if we have the particle size smaller than the 10 micron or 20 micron? There is a low probability of collision between the particle and the bubble. So decreasing the particle recovery percentage. If you have the higher than 100 micron or 200 micron, higher the detachment probability from the detachment probability of the particles from the air bubbles. So decreasing the recovery of the particle. Next slide, please. Yep. So in relation to what I mentioned, together with what people reported in terms of the geometallurgical aspect of lunar resources. So there is one report studied the particle size distribution of the regular stimulant plotted here. So indicating the presence of ultrafine particle minus 20 micron existed about 20%, which means about that size, about that population of the particle can be difficult to be treated properly processed by existing mineral processing separation methods. So those such significant quantity of the materials can be regarded as waste and then maybe sent to the waste tailing dams facilities. So it is clearly telling us the necessity of the development of the new methods that still can work even under the extreme moon environment, including limited access to the water and temperature variant during the day. Next slide, please. So in addition to the particle size, what we want to have is a good dispersion and liberation of the different minerals after the size reduction of the ore. So what we want to have once we have the ore from the mining site is to reduce the size to fit the particle size range to the specific size range required for the separation methods. In addition, we would like to have the good dispersion of the different different minerals that will allow us to do the selective particle recovery, which carries valuable minerals. So indicating the higher the degree of liberation, higher the degree of dispersion of the target mineral, leading to the selective mineral separation recovery. So here you have the particle flotation recovery as a function of degree of liberation, indicating the higher degree of liberation, higher the particle recovery by flotation. Next slide, please. So one report studied the degree of liberation of the ilmenite minerals against the physical separation method. Yeah. Confirmed the general trend between the degree of liberation and the selective separation, meaning that higher the degree of liberation, higher the separation performance, lower the degree of liberation, smaller the poorer the separation results. Next slide, please. So in the view of geometallurgy, the mineral recovery point of view, detailed maps of the minerals of specific ore bodies would be of great help. Mineral maps based on the drill core logging type method would be appreciated. Yeah. For example, here you have one mineral map based indicating the gold mineralization with two different concentration. So this kind of information can be very helpful for us to target where we can excavate and then extracting the ores, which can be further processed in the separation operations. Next slide, please.
2 minutes.
Yeah. So through the literature review, what we identify is research is focusing on the beneficiation recovery of potential minerals, but not at all about the potential waste which we could generate after the recovery process. So I'd like to emphasize on the study of those waste rocks and process residues, as well as how we storage those waste is to be encouraged to do the study to perform in order to prevent environmental and health issues. So in this schematic explaining the series of events we have in the mining operations, starting from the mining ore excavation, followed by the mineral processing to separate the valuable minerals, separating and rejecting the non-valuable minerals. So those non-valuable minerals is stored in the storage dam, so-called tailings dam. But if we have the poor management of those tailings dams, we could have the potential disaster happened in the past in the different places of the world. So we better avoid those kind of disaster happened, and better be prepared for those kind of avoidance even before start planning the mining operations. Yep. Oh, next slide, please. So this is just a summary of what my talk. So yeah, next slide, please. So thank you for your attention. So if you have any question, I'll be happy to answer them.